So now that we can identify a Poisson scenario and we can calculate probabilities for that scenario, the last thing we need to be able to do is the last thing we did with our binomial distributions. We need to be able to calculate the mean and standard deviation for a distribution. And you see what I've done here, right? I've set up, these are the same three parameters that we had in our formula. And these are our formulas for the mean and standard deviation. The mean is the average rate times the time, and the standard deviation is just the square root of the mean. Okay, so the way I remember this, think about what I'm saying there with that mean. Let's say we have an average of 5. I'm thinking about the fish example I've been using. We have an average of 5 fish per hour, right? And my time length that I'm looking at is 2 hours. Well, how many would you expect to come through? I mean, that really is what this mean is, right? It's the expected value of the distribution. How many will we expect to come through? Well, if we're averaging 5 per hour and we're looking at a 2-hour window, then on average you would expect 5 times 2, that's 10, right? That's all that parameter is saying. Okay, so speaking of salmon, right, I'm back to my salmon scenario here. And I've got kind of our usual question. Would it be unusual for 7 fish to pass through the checkpoint in 2 hours? And this is we looked at the probability of this earlier. It came out to 9%, if I remember right. So now we're asking this question, is this unusual? And I'm going to use my standard plus or minus 2 standard deviations rule. All right, so first let's organize our values here. X is 7 fish. Lambda is 5 fish per hour. And T is 2 hours. And again, right, we've got that same quick check. Time units are the same, right? So we don't have to worry about making any conversions. All right, so where do we end up? Let's see, the mean is lambda times T, which is 5 times 2, or 10. And the standard deviation is the square root of the mean, which is the square root of 10, which is, according to my calculator, 3.162. So what's my usual range? Remember how we do this? We're going to do the mean plus 2 standard deviations. And down here, we're going to do the mean minus 2 standard deviations. And see where our x value falls. And see if that's in this interval or not. All right, well, 10 minus 2 times 3.16, that's 3.676. And if I add 2 times 3.16, we get 16.324. 7 does fall between those two numbers, right? So we would not, so my answer is we would not normally consider it unusual for only 7 fish to come through. It's not a high probability, right? But it's not sufficiently low that we would kind of consider this an unusual result. So where are we going next? Well, this really ends our discussion of discrete distributions. Right? There are others. There's a wide variety of these things, cover all sorts of different situations. We're going to stop with these two. And so in the next series of lectures, in the next chapter here, we're going to kind of do the obvious next thing. Now that we've seen about how discrete distributions work, our next step is going to be to kind of give the same treatment to continuous distributions.